Welcome back, my geometrically minded minions and minionettes. Well, we continue to talk about triangle congruence and looking at these. And we've been saying triangle congruence. What does it take? Well, we've got to prove that three corresponding sides are congruent, and then three pairs of corresponding angles are congruent. And we said from this last video, we said, oh, there's got to be a shortcut. There's got to be a faster way. So up to this point, we've found a couple of faster ways. We said that, we can use side, side, side. That's a shortcut for us. And we've also said, hey, well, you know what? If we've got side, 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 we can also use side, angle, side. Well, the question is, isn't there any other way? There's got to be more hope. There's got to be something else for us. And the good news for you is the answer is yes. We're going to look at tonight. We're going to examine a couple of other ways to some more shortcuts to triangle congruence. So let's jump right in here and let's talk about these. So the first one is called angle, side angle. Well, angle, side angle, or in other words, it's going to be ASA as our abbreviation. Well, this one simply says that if we have two triangles, okay, and here again, me and my rough sketches. So if we have two triangles, if we can prove that one angle, one pair of corresponding angles, and then finally a second set of corresponding angles, notice an angle, side angle, we've got two angles, and the side, where is that side? It's between the two angles. So angle, angle, hey, there we go. So it's the side in between. If we can prove that two angles are congruent and the sides in between those angles, those corresponding sides are congruent, that is enough. And that is enough for angle, side, angle. So there's a shortcut. And then the other one that we're going to look at tonight is called angle, angle, side. Well, this is very much, I almost said similar. This is very much like the one we said before. So notice that we have two pairs of corresponding angles, but this time the side is not between them. So this one here, we've got a little bit of choice. This just means any of the other two sides, as long as it's not the side that's in between it, it would be angle, angle, side. So notice angle, angle, and let's just say that we prove this side congruent to this one. Okay, that would be angle, angle, side. Well, does it have to be that one right there? No, it doesn't have to be. So for angle, 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 side, if I can get it, there we go. What if we had proved this side congruent to this one? Is that angle, angle, side? Angle, angle, yes, it's a side outside. So angle, angle, side. Now, does angle, side, side work? Well, angle, side, side. No, if we have two sides and an angle that's outside of them, there is an endless possibilities there. So, and ask about the joke for this one when you get to class. So ask about that one, ask about the joke when you get to class, and we'll go into that one a little more. But no, there is not an angle side side for triangles, just an angle side side for people. So let's look at these. Now, state if these two triangles are congruent down here. So why don't we go ahead and why don't you hit the pause button right here, and let's take a look at these down here at the bottom. And let's see if you can figure out if they are congruent or not. If so, what the reason is. And then we will come back and look at them in just a moment. Welcome back. Let's take a look here. And the first one right here, notice we've got one pair of corresponding angles, second pair of corresponding angles, and a side. Well, where's the side? Is it between the two angles? No. So this one is angle, angle, side. So that one works right there. So let's look at this next one over here. Well, we've got an angle here. We've got this side. Oh, that's all we've got. Oh, no, it's not. Because guess what? Good old dependable vertical angles. So now we have angle, side, angle. We've got the side in between two angles. So look at here. Now, looking at this one, we've got this angle congruent to this angle. We've got another angle congruent to another angle over here. And hey, we don't have anything else. We don't have an angle angle. Oh, yes, we do. Look at this. Reflexive property says this one is angle, side, angle as well. So we've got two angles, a side in between. All right. So let's take a look at this one. Now, we've got an angle congruent to an angle. We've got this side here. What else do we have? Well, we've got old trusty vertical angles. So what do we have? We've got two angles and a side. The side isn't between it, so this is angle, angle, side. All right, so let's look at this next one. We've got this side congruent to this side congruent to this side. Angle in between. The angle in between. Oh, the angle's not in between. Oops, sorry, they're not corresponding. That's not going to work. All right, so let's look up here. We've got this angle congruent to this angle. Well, obviously they're sharing the same side, so we've got a side. Oh, we've got this one right angle. We don't know anything. Aha, but yes, we do, because this is a line. Definition of linear pairs says that these two have to be supplementary. So if this is 90, this angle has to be 90 as well. So we have angle, side, angle, because all right angles are congruent. All right, so let's look here. We've got an angle, we've got a side, and we've got another side. Angle, side, side. No, that's not going to work. If that angle had been the angle between those two sides, we could have used angle, side, angle, but not in this case. All right, so let's look here. We've got an angle congruent to this angle, angle here. Hey, they share a common side. Well, this third angle has to be congruent. So we don't have can we go angle, angle, side here? Yes, we could go angle, angle, side. Hey, you want to know what the other cool thing is? By the third angle theorem, says that if two angles of one triangle are congruent to two angles of another triangle, then the third angle must be congruent as well. That's that third angle theorem we talked about a couple nights ago. Now, if you did that, guess what? Angle, side, angle. So we could use angle, side, angle using the third angle theorem. Ooh. All right, and finally, this last one. What do we have? Side congruent to a side congruent to a side, two sides. That's not enough. But reflexive property says they're congruent. So guess what? Side, side, side. Here we have three sides congruent. All right, well, you're getting pretty good at this one. So let's take a look and let's see if we can't go on to the next one. Let's take a look at a couple of proofs here. Let me go ahead and shrink my pencil down here just a little bit. Let's see what we got. Well, given angle X is congruent to angle I. So let's see. We can go ahead and put a congruent mark here. Those two angles are congruent. And XJ here is parallel to IH. Okay, well, so let's go up here. First of all, we got this given statement right here. We're trying to prove that the two triangles are congruent. Well, we've got an angle. That's a good start. Well, I guess we could go ahead. Let's just go ahead and take a look at this. JH has got to be congruent to itself, right? So good old-fashioned mirror, mirror on the wall reflexive property. So angle or segment JH is congruent to segment JH. That's the reflexive property. So we can go with that one. Now, let's go with this parallel line thing. Well, if those two lines are, these two sides are parallel, then that makes this HJ here a transversal. So notice that we have this angle right here formed by parallel line on the transversal. This, well, if my pen is going to work tonight, this angle here formed by the transversal. So we can say that angle XJH is congruent to angle IHJ by alternate interior angles are congruent. We had that postulate that said alternate interior angles are congruent. So now let's take a look at what we've got. Hey, we've got two angles and we've got a side. So are these two triangles congruent? Yes, they are. Triangle JHI is congruent to triangle HJX by what reason? By angle, angle, side. So can we prove them? Absolutely, with angle, angle, side. All right, so second one. You might want to try this one on your own. If so, go ahead and hit pause. If not, let's go ahead and walk through this together. So we start with AC is congruent to BC. So AC is congruent to BC. It's an interesting note there. CP is perpendicular to AB. Well, that's kind of interesting right there. Doesn't really tell us anything. It kind of leads us somewhere if we can think about it. So let's start with our given. Now, from our given, let's go ahead. Let's deal with this CP is perpendicular to AB. What does it mean to be perpendicular? Well, it means that it forms right angles. So what we need to say is that angle APC and angle BPC are right angles. Oops. Let's call that, please excuse my inability to spell tonight. So our right angles, why? That is the definition of perpendicular. Okay, so once we said that, now we can say that angle APC is congruent to angle BPC. because we have that wonderful postulate that says all right angles are congruent. So because we have these two are right angles, we can say that they are congruent to each other. All right, so we're looking at that. Now, looking at where we go. Well, hey, let's go back up here. When we said that AC is congruent to CB, basically what we were saying is that that is an isosceles triangle. Well, if those two sides are congruent, what do we know? That angle A must be congruent to angle B by what reason? By the isosceles triangle theorem. Okay, so angle A here has to be congruent to angle B by the isosceles triangle theorem. Hey, well, take a look at what we've got right here. We've got this side, we've got two angles. So what can we say now? We can go ahead and say that angle, or the triangle ACP is congruent to triangle BCP. By what reason? By angle, side. Well, I know some of you are going, hey, there's still one more blank. Well, who cares? We're just good that way. We just got there with only taking 5 and didn't need our 6 steps. So good job. You're ahead of the curve. All right, so let's take a look at this one. The corollary to the isosceles triangle theorem. It says if a triangle is equilateral, then, we've already talked about this one, then it is also equiangular. So in other words, if we look at a triangle, so if a triangle is equilateral, so in other words, if we look at these, and this is x, y, and z, if xy is congruent to yz, congruent to zx, then what has to be true then in that same triangle with, don't know where that came from, x, y, z, then what has to be true? Then angle x has to be congruent to angle y, has to be congruent to angle z. So, and then the converse of that one, if a triangle is equiangular, then it is also equilateral. It is also equilateral. So the converse of that drawing would work if we've got a triangle drawn so that x, y, and z, if those angles are all congruent to each other, then what must be true? Then in that same triangle, in triangle x, y, z, then xy must be congruent to yz, must be congruent to xz. So that's where it is. All right, so as we're wrapping this thing up, you've got a little bit of algebra review. Go ahead and hit pause right here. Get your algebra review done, and then I'll pop the answers up for you, and we'll look at this one. So hopefully this has helped. We've got a couple more shortcuts now. We're down to 4 shortcuts, as well as the 6 things we can prove triangles are congruent. So you're on your way to being a very effective practitioner of proofs. As we wrap these up, the first solve, obviously we've got a little distributive property here, so be careful and make sure you take this -3 times 2x and then the -3 times -4. That's the one you really got to be careful about right there. So in this next step, notice we combine -7 and 12. That gets us a +5. This 3x and -6x gives us -3x. Just really kind of rolling from there. This bottom one down here, we are cross multiplying. Here again, make sure that you multiply this 6 by everything up here, by the x and the 2. Multiply this 4 times this 2x minus 1. So as we get everything there, and we're solving from there. The second one, the graph, we've got y equals -1/2 x plus 0, going through our origin, negative slope of 1/2, so we're good there. The bottom one, going through the origin again, plus 0. Just 1/1, straight old-fashioned. This one here, distributive property, 2x times 3x, 2x times 4, -3, be careful, -3 times 3x, -3 times +4, and then the last one we're just factoring. So hopefully we're getting pretty good at that. We've gotten another series of these along the way, so bring your questions to class. Make sure you go ahead and summarize your notes on your own. Summarize your own notes, rewrite it your way. Don't just copy mine down, and we will see you tomorrow.